In this first MCA homeroom lesson, we'll be working on solving one-step equations. This is a 6th grade MCA standard, and you'll see questions like this when you take the MCA test in April or May. The method that we're going to be using to solve these equations today is called solving one-step equations by undoing. And it's called undoing because when we look at an equation, we're going to do the opposite of whatever the equation says to begin with. So looking at this first equation, I'd like to divide the equation at the equal sign. And you should take the same notes in your notes packet. So you'll divide the equation by putting a line straight underneath the equal sign. That divides the equation into two parts. And the equals is telling us that those two parts are perfectly balanced. X plus 6 is exactly equal to 14. And we're trying to figure out what x is. The way of solving this by undoing, we notice that it says plus 6, and we want to get rid of that. We want to do the opposite, and the opposite of adding is subtracting. So we'll put minus 6 right underneath it. Anything we do on one side of the equation, we have to do on the other side, because we want to keep the equation balanced. On the left-hand side, plus 6 minus 6 is equal to 0. So I can cross that off, and that leaves me with just an x, and that's perfect. That's what we want. On the right-hand side, 14 minus 6 is 8, and that's the answer. So now I know that the variable of x is equal to 8. And if I wanted to check that, I could put that back into the equation, put an 8 in here, and just try 8 plus 6 and see that it really equals 14, and it does. So we checked it and we got it right. The next problem, I'm going to put a line down from the equal sign again to divide the equation into two parts. I want the x to be by itself. This time the problem says x minus 11. And remember, we're undoing things, so the opposite of subtracting 11 is to add 11. Adding and subtracting are opposites. If I add 11 on one side of the line, I have to add it on the other side. Minus 11 plus 11 cancels out, and 45 plus 11 is 56. So now I know that the answer is 56. And if I wanted to check it again, I could go to the equation and put in a 56 and try 56 minus 11, and I would get 45. I know my answer is correct. I checked it. In this equation, it's a multiplication equation. The dot means to multiply. So when I'm trying to solve this and I want to get w by itself, I have to undo multiplication. And the way to undo multiplication is to divide. So if it says times 8, I'm going to be dividing both sides of the equation by 8. 8 divided by 8 turns into a 1. And we could put a 1 there, but usually we wouldn't, because 1w and w are really just the same thing. So I'm just going to put w. On the right-hand side of the equation, it says to do 56 divided by 8. If you're typing this into your calculator, you want to make sure to put the top number in your calculator first. We do top number divided by bottom number. 56 divided by 8 is 7, so now we know that w is equal to 7. If you wanted to check your answer, you could put 7 right here. 8 times 7 really is 56. We checked it, and it works. This problem, I'm going to put the line in under the equal sign, but then I'm not sure, I don't see an operation here. I don't see add, subtract, multiply, or divide. But I know that when a variable and a number are right next to each other, it means to multiply. So it's just like if there was a multiplication symbol in there. So just like in the last problem, I'm going to be dividing to undo the multiplication. I'll be dividing both sides of the equation by 13. Multiplying by 13 and dividing by 13 cancels each other out. And 65 divided by 13 is 5. So I have the answer. Now this problem, sometimes people get stuck on these, so let's pay attention to this one, and then hopefully when you do the practice sets, you'll remember what to do here. It just looks a little different than the others. It looks like a fraction, and it is a fraction, but fractions mean to divide. So this problem really says w divided by 4. What I want to do is undo dividing by 4, and that means I'll be multiplying by 4. So I'm going to multiply both sides of the equation by 4. Dividing by 4 and multiplying by 4 cancel each other out, and I'll end up with w equals 28. 7 times 4 is 28. I can check the problem by putting a 28 in place of W. 28 divided by 4 really equals 7. That worked. So, yep, I got it right. In the two word problems, we want to model the problem and solve it. So let's see. This one says Samantha found D perfect sand dollars on the beach. She gave 15 of them to her friends. She kept 8 for herself. We have two things to do. Write an equation to model the situation and solve the equation. When we write the model of the equation, we want to go in the same order that the word problem goes in. So if it says Samantha found D perfect sand dollars, that's what it says first. We're going to start with D perfect sand dollars. Then it says that she gave 15 of them to her friends. That's what happens next. And we'll show that she's giving away 15 by putting minus 15. The last thing is she kept 8 for herself, so in our equation we'll show that that equals 8 for her to keep for herself. We're done with the writing in a model, and now we'll move on to the solving part. So I'm going to split the equation just like I did in the previous problems. I want to get the D by itself. I need to undo minus 15, so I'll be adding 15. Minus 15 plus 15 is nothing, it's 0. And 8 plus 15 is 23. Then we'll know that she started with 23 sand dollars. In this problem, it says Josie wanted to spend her money, M, evenly on each of the 4 days of her vacation. She figured she could spend $35 each day. And again, we have two things to do. Write an equation to model the situation and solve the equation to see how much money she started with. So I will go in the same order as the word problem. And it looks like Josie wanted to spend her money M. That means she started with M for money. And she wanted to spend it evenly on each of the 4 days. That means she wants to take her money and divide it by 4. She figured she could spend $35 each day, so it would equal $35 for each day. Now we want to solve this. This left side of the equation says M divided by 4. The opposite of dividing by 4 is to multiply by 4. And whatever I do on one side of the equation, I have to do on the other side. The 4's will cancel each other out, and 35 times 4 is 140. And so now we'll know that Josie started with $140.